Epstein here. You can start the podcast whenever you'd like.
Really? maybe we already have.
We already did.
Yeah, so
could be.
Yeah, we always. That's the only way you can get outtakes.
Yes,
outtakes
is to make them at the beginning.
Yes, we take them out.
It's going to be a great day.
Yeah.
This whole podcast is outtakes.
I hadn't noticed that. Oh, Harry's got a boom. Look at that.
I do. I've had a boom. I'm a professional podcaster. Welcome back to Bufnagely podcast, where we talk about all things good in the pursuit of the adventure of life. I'm Harry, and we have a smorgasbord of guests and big brain smart heads and all kinds of fun individuals today. The pre-production meeting, Rafe, was quite lively, and now it's toned down a bit.
Well, we're taking a little risk today, and we're putting Bob on the spot. But we've brought a backup for him. Bob Luzenski, America's favorite rocket scientist, is here, along with my brother, Dr. Brian Donahue, who is America's favorite ham radio time traveling anesthesiologist. And we're going to, before we get started, I have to thank our listeners, because we have the world's greatest listeners, because through some miracle of the interwebs, we are a global top 10% podcast. As usual, you can reach us at bufnagely.com. Remember to share the love, share the buff, give us a 5-star review, subscribe, hit the like button, hit the smiley star button, follow, join on, get on the bandwagon, tell your friend to listen and get a free episode. You know the shtick, but you know what? Get with it. Follow the shtick and do what you need to do. Bob, it's good to see you. Brian, how are you guys?
I'm good. Always good to be on the buff. Not sure what's going to happen here, but it'll be fine.
Well, Brian knows the general direction of this, and this kind of starts.
So I'm the only one who doesn't know.
You are the only one that is.
And for the listeners' benefit here, I got a text message on Thursday from Rafe, and it says, it was to Rafe and Harry, and it says, I have an idea for a rocket-based episode. I want to ask Bob a question cold just to see how he responds, but also want real answers. So want to give him time to think about it.
As if you wouldn't get real answers.
Well,
we've just been making up science on the spot for the past 3 years.
Well, we will get answers, and that's kind of Brian's role here is to have a little bit of he knows where this is going, so he kind of probably has some of these things at least thought through a little bit. Although, Brian, I'm certainly putting you on the spot in that way a little bit, right?
Oh yeah, a little bit, not much.
All right. Okay. So here's Bob. Here's where it starts, and I think I sent all of you this sometime last week. There was a press release that came out, not from NASA, but from the New Elementary website, which is a website that tracks new Lego parts. And you may think that's kind of a bizarre thing, but when new sets come out, they say, "Hey, look, here's a new piece that's in green," or here's a brick with 5 studs on it or something like that. And they had announced that there are 2 new space-based, I'll call them space-based Lego sets. And one is a rendition of the NASA SLS, which is the Space Launch System rocket, and the, what do we call it, Bob? The gantry tower? Is that the thing?
Well, I don't know what the exact mobile launch tower. Let's go.
Mobile launch there. Okay, so the set comes with that, and it's pretty big, and it will look great in your office if you get it. And then the other one is more of an art piece, which is a Lego mosaic rendition of our galaxy, not viewed from Earth. Okay, it's viewed not from Earth. So it's a big swirly thing made up of a lot of pieces, and it's like any good mosaic. When you zoom way in, you see weird stuff, but when you zoom out and kind of squint your eyes, you're like, "Holy cow, look, that's the Milky Way galaxy." So that was the first thing I saw. And then I started, Brian and I were talking about this and other rocket-related things, and we came across, with the SLS, there's a piece that has I think a big sticker on it that tells you pertinent facts about the SLS. And one of them is that the weight of the rocket was 5.75 million pounds. The max thrust was 8.8 million pounds. And it's nice to note that the max thrust is greater than the max weight, right?
Thrust to weight ratio greater than 1, yes.
Yes. And then, and the thing that got me, though, was this was this statement that said time to orbit 3 minutes and 40 seconds.
And that's wrong.
Well, okay, so that's see. This is
Lego
why
was listening.
This was your question? This
is just the lead up to the question. But I'll stop right here. And why don't you tell me what the time to orbit is if it's not 3 minutes and 40 seconds?
It's probably 8 minutes and 40 seconds. That would be closer to right.
Okay.
So 3 minutes and 40 seconds is definitely wrong. It's a typo. It's shocking that it's a typo.
Well, so for what it's worth, in that regard, there is another picture on that in that set of pictures they send out. There's another picture, and it says, it says that the height of this space launch system is, I'm going to say this in quotes now, it is 98 meter. It doesn't say 98 meters. It just says 98 meter. And I thought, well, okay, so maybe
it's METRE.
METER. Right, but no S on the end. It was like, that seems a little odd to me. And it seems like maybe this was like, yeah, I don't know. Is this a first draft? Is that the kind of, have they printed all the stickers? Because it seems to me, Bob, they need to reprint the time to orbit, and they need to add an S on the end of the meters, right? Is that
as a minimum? Yeah, but the other thought that crosses my mind, and I actually saw a picture of this set. My brother's oldest, one of my nephews, sent a picture of it, and he had seen it somewhere. I don't exactly remember where. He sent a picture of it and said, "Hey, look at this new set," and it had the box and everything, but it didn't have. I didn't see anything more than that, and it looks cool. I mean, it looks like a cool set. If it's really a real Lego set, it's a really nice looking set. But the other thing that occurred to me is, is it for real?
Well, I think it is for real. I think we're a little bit past April. That's a big thing on April 1st this
was April, late April.
And you've seen that one that's just a box of gray bricks, and it's entitled Alderon. It's just
oh, nice.
you just dump it on the floor.
Wow,
that's awful.
That's a little rough.
That is awful.
But okay, so anyway, so I saw this and I started thinking about this time to orbit 3 minutes and 40 seconds. That seemed awfully short to me, and now I'm hearing they're off by about a factor of 2. Like, well, okay, but there's a short thing there. Like, how long did it take? Okay, so here's the first question, and these are lead up questions. Is that relative to the Saturn V? What do you remember?
It's going to be I would expect the SLS time to orbit that length of time to be similar to the space shuttle, and the space shuttle was on the order of 8.5 minutes. And if it's a typo, the 3 should be an 8. Then 8 minutes and 40 seconds makes a lot of sense. The Saturn V was, I want to say it was like 12.5 minutes.
Okay.
Is what I remember. And it's been a long time and I've slept since then, but I believe it was closer to like 12.5 minutes.
Okay. But it's still in the neighborhood. It's not several hours.
You have to get up and get going. You need to get above the atmosphere, and you need to get moving sideways rather than up. And you need to be moving at 25,000 meters per second or 17,500 miles per hour.
Well, see, okay,
or 25,000 kilometers per hour.
Okay, so I just looked this up somewhere. And this is where I'm like, holy cow, is there this much bad information on the interwebs? Because
not at all.
It's written by AI, probably.
Well, I wanted to.
We all know AI is an expert system, and it makes stuff up.
Well, okay, AI is another question, because we've had episodes on AI.
AI would be a great guest for this podcast.
Well, AI would just okay. So We will get to the question. I did some things yesterday. I need to go. I announced last week I'm going to Europe for this thing this summer, and I'm looking for airfare, how to get over there. And the question is, do I fly out of Indianapolis? Do I drive to Chicago and leave from there? Do I go to Cincinnati? Maybe there's a special flight out of Dayton or Peoria, or I don't know, some one of those things.
Drive to Toronto.
Right. So I had a list of, like, I'll call them departure cities, and a list of arrival cities. Like, should I fly into Paris? Should I fly into Copenhagen? Should I fly into Amsterdam? Should I fly into Zurich? I mean, all these other things. And I figured, so I went to the Bing Copilot thing. And I said, because Bing is my Copilot.
I'm sorry. This is already too funny for me.
Well, it's just...
Keep going, though. Keep going. No, really, keep going.
And I said, so build me a grid of these departure cities to these arrival, every combination of these. I didn't say it that way. So from these departure cities to these arrival cities on this date, and give me the lowest airfare on that. And it came back with like $79, $67, $99. And I knew that couldn't be right. And then it gave me like a list of, here's, you can go from Chicago to Amsterdam for $79. I was like, what? That's not right, because I just did another one. So, so then I said, well, make it a grid. Make the departure city the rows, the arrival cities the columns, and put the numbers in there. And it couldn't do it. It just kept giving me the same thing over and over and over again. And I kept, I tried to build it up, do it from here to here. Okay, now do it from these. And it just couldn't do it. All right. Let me rephrase that. I couldn't get it to do it. And it just became, I'll just make a chart and I'll do it myself, is what I thought, because I don't have artificial intelligence. I have actual stupidity, but at least I'll take that over what it was giving me. Okay. So anyway, I looked this up today and I just went to the Google machine. I figure escape velocity in miles per hour. And this one says it's 25,000 miles an hour or 11,000 meters per second. And
okay, that's escape velocity.
Is that different than orbital velocity?
Yeah,
yes, you're right. Yes, it is. Yes, it is. Yes, okay, because it depends on the altitude. Okay. See, I told you I have actual stupidity, not artificial intelligence.
Brian's got an addition here for you, though, Rafe.
What's he got?
No, I was going to say escape velocity it's the inverse of the velocity that something would proceed if you let it come from infinity through the gravitational field, accelerated until it smashes into the Earth. The opposite of that is escape velocity.
So that's if you just had it's like if you go up to like Saturn. So if I go to Saturn and I just toss a golf ball toward Earth, and I get it into the well, and it starts
gravitational field,
and it falls down there, and I suck all the air off the planet so it doesn't slow down.
Of course, all these real things,
We'll hold our breath.
Well, thank you. So I can do the experiment. That's the velocity. Okay, and that's escape velocity.
So if you think the opposite of that is, now if it's going in that same direction, or same velocity but in the other direction, it'll get to infinity.
It'll get onto the top of the okay.
It'll escape the gravitational field. Yeah.
Okay. So all right. So you're of the belief, you're going to make the statement. You're going to make the statement that orbital velocity is what you said. What did you say? 17,000 miles an hour.
Yeah, 17,500.
Okay. Okay, that's great, because that's what I thought it was. And
to a nominal, low Earth orbit.
Okay, so I started thinking about this time to orbit, and that's not time to space, because it's easy to get to space. All you need is a balloon that doesn't break real easily, and just put I've seen people put like Lego in space, right? They take a minifig and a camera and they put it on there, and it just goes up, and eventually the balloon pops and the poor little guy falls back down. So space is easy in that sense. All right. But orbit is harder, because it's not about going high. It's about going fast. All right. So my question was this: how do we do it? So so if I took your Estes rocket, right, that you normally launch from Earth here, and I loaded up, okay, so I know there's the weight to thrust ratio and all this kind of thing. You got to get it going before you can even get it going faster. Can I lift the rocket up like with the balloon? All right. And then when it gets to space, I trigger the engine. air. I know we need air or oxygen to make it go, but like, what can I do that? How can we get it going like that? What's the easiest way to make it do that? What's the easiest way for me to put something in orbit, I guess is the question.
Contact your local FSDO, get in contact with the FAA, and request some balloon clearance probably.
Well, but let's say I think I can get something pretty high in the atmosphere pretty quick with a balloon. Right? I mean, there was a guy that I can make a lawn chair fly.
People do that all the time.
Yes.
It happens.
Yeah.
So the question you're asking is what is, okay, let me make sure I understand the question you're asking, because I feel like you're asking one of two questions and I'm not sure which one it is. One is, how do you use a balloon to get something into space, or how do you get into space? How do you
I think he's asking how high up do I need to get in order to go orthogonal to gravity such that I can reach orbit?
I'm not even asking that. I'm saying I want to put something in orbit. Okay. I want to put something in orbit, and I can get something up at the top of, I'm going to say the top of, I realize that's not really well defined, the top of the atmosphere. I can get I get above the air. I realize that's loose. Okay. But I can get up where the air resistance is pretty minimal.
Mm-hmm.
And like, if I did that, could I create a thing that was smaller than that rocket that Goddard always shows? Could I create a thing that is, that would make it orbit?
Theoretically?
Well,
maybe.
Well, is there a way? How would I do it?
To me, if you wanted to get something into orbit, you should contact the salespeople at SpaceX
and ask to
put them, because
put this shoebox in orbit for me.
Here's the thing, Rafe. This is a Rafe style question.
Yes, it is.
And I will address it at one point. But first, I want to say, because I've had this question before, this question about, well, why couldn't you use like an airplane and then launch a rocket from the airplane? Why isn't that the way to go? Or like you're saying, basically go straight up and then go horizontal instead of starting to go horizontal, launching horizontal and then, with the rocket and then tilting over as quickly as possible and go, get out of the atmosphere. And if there was an easier way than the way we've been doing it for the past 60 some odd years, they would be doing that.
Well, but it seems to me they want to put like real things in orbit, like satellites, and I don't know, things that are eventually going to go to the moon or to the Mars. But what if let's say I had a really small thing I want to put into orbit, like I'm talking like really small, like an Estes rocket. Is that?
Well, let's say a minifig. You want to put a minifig?
I want to put a minifig in orbit. Yeah.
Okay, because that's a really small thing. It's light. It's small, and it's cool. You can even make it a little spaceman.
Little spaceman with a little helmet with this little visor on.
Yeah, with his visor down. So he doesn't get bothered by the sun.
I can put that oxygen thing on his back.
That would be good.
Yeah.
So, I would put it. I would take the minifig guy. I would put him in a CubeSat, and then I would find somebody that's launching CubeSats.
Wait. What? A CubeSat? A cube satellite? Small satellite?
Yeah,
Brian, go, Brian.
Yeah, Brian knows about this.
Amateur radio clubs do this all the time. The group at Vanderbilt just launched a CubeSat a few years ago. They're about the size.
Is it like 100 millimeters or something on a side? It's some
like 10 by 10 centimeters.
It's a cube.
Yeah, and
that's why they call it a CubeSat.
Mm-hmm.
And lots of universities and high schools and lots of groups launch CubeSats, but they don't. They focus on the sat part, and they hitch a ride wherever they can. In fact, one of the guys I used to work with had a part of his university when he was at U of M. University of Michigan. He worked on a CubeSat project, and they were getting a launch through NASA. NASA has a CubeSat launch program. I can't remember exactly what it's called, and they were helping students get their projects into orbit. And
so you can call them up and you say, I have a CubeSat I would like to put into orbit, and they just, what is it, like $100, $1,000, $10,000?
it's
Do you know?
probably not $100. So first of all, you have their requirements for the CubeSat, and there are requirements for how it behaves and everything. So you got to meet all the requirements to get a ride, to get on a rocket. And obviously it has to be safe for the rocket, because you're not a primary payload. You're a secondary or tertiary payload.
What's past tertiary?
Yeah, you tell me.
Okay.
You're the math guy.
I would say quaternary, but that's all right.
Okay. We want to keep our listeners with us, though.
Yes, if they're still here.
However, the two that are still listening to this nonsense. So you have to meet all these requirements. It can't be powered up until it's deployed, that kind of thing. And then you design your CubeSat to do whatever it is you want to do with the CubeSat. I mean, if we're talking about our minifig guy, you would put maybe a camera inside the CubeSat and the minifig, so we would float around and bounce around. And then, of course, Brian would have to make a radio so that we could get the pictures back of the minifig floating around inside the CubeSat. And maybe if we really wanted to be cool about it, we would have a door so that we could
send him on a spacewalk
outside the CubeSat, and then figure out a way to reel it back in
with a little minifig T-shirt that says "Listen to the Buff."
Yes. It'll probably be one of those little Lego wrenches, like from one of the old pirate ships. He's just attached to his neck. Reel out and reel back in.
There you go.
That's what we'll do.
Yes. So,
wow. Okay.
So yeah, I mean, all those things can be done, and then of course, if you're broadcasting, video back of our spacewalking minifig, then you'd have to have accommodations for receiving those signals on the ground.
That's why we have the Worldwide Ham Radio Network.
Yes, something
the Bufnagely Worldwide Ham Radio Network.
Yep.
Yeah. Okay. All right. That's what we would do.
I won't even ask how many locations around the world, the worldwide.
It's a volunteer organized Bufnagely Worldwide Ham Radio Network. Okay.
Yeah. So these are all things that are possible.
So when they launch these things, so you both mentioned that there were lots of these that go up. Are they launching like dozens a week, 50 a year, 100 a day?
I don't even know what the number is anymore. I know that SpaceX, again, has a ride share that they do frequently now, where they launch all kinds of small sats. So, and a common orbit they want to go to is polar orbit. So they'll launch into a polar orbit and deploy 50 or 100 satellites.
Do they just kind of like just open the door and drop them?
Well, there's a standard mechanism for deploying CubeSats. And
like the Pez dispenser thing.
Standard deployers. It's not really a Pez dispenser. It's more like a pop the door open and the spring pushes the thing out. It's pretty low tech because you want it to work. And you don't want to put a lot of demands on the launcher. Basically, the launcher sends a signal, says, open it up. It opens up, then comes out. So,
okay.
And there's actually there are companies who are building satellites that will take your CubeSat from that launch to whatever orbit you want.
Boost it.
Yeah, put it in. If you don't want to be exactly in that orbit, you want to be maybe in a different plane, or you want to be higher up, then there's services now that will take take your satellite to different orbits once it's up in space.
Whoa.
Yeah. How cool is that?
Well, see, that is something. This is one of those things, like a lot of things that I learn, is it's so obvious to me right now that that's a thing. I was like, why would there not? When you started talking about deploying them, I'm like, there's got to be somebody who's making money by taking them and moving them around, right?
And there is.
And wow, how come no one ever told me about this? How come this is not in our space curriculum?
How come you've
never asked?
I haven't ever asked. I think that's exactly the issue. All right. Well, now, okay. So you answered my question. That's the best way to do that, and I could do that for a probably not an insignificant fee, but probably one that's within the ballpark of the I was going to say the committed adult, but that word has multiple meanings.
You would have to compete more than you would have to pay.
Oh, you think I have to
You would have to compete. There's multiple universities, multiple different programs, aeronautical, astronomical societies, groups, individuals that compete to have their specific CubeSats sent into orbit.
Oh, so you have to.
In the past 4 minutes, as you were discussing your desire to send the buff and the little minifig T-shirt onto a spacewalk. But yeah, you would have to compete more than you would have to pay.
So you have to write like a grant application kind of thing, why it's good and important, and why the future of the free world depends on it, that sort of thing.
How are you contributing to mankind?
Well,
that is a good question.
Isn't that obvious? So,
I don't know that I could answer that question.
Wow. Okay. Okay.
Other than appearing here on the Buff on occasion.
Yes. Okay. So
now, but what I guess I want to say in response to Harry is, you would, if you were doing something that was, say, scientifically valid or
less whimsical,
worthwhile, less whimsical, but something that was along the lines of a marketing gimmick for Bufnagely Enterprises. Remind me, it's.
We can go with we could just it's probably Bufnagely. You could probably call it Bufnagely Enterprises for this.
Okay, so the advertising space program for Bufnagely would probably not need to bother applying for a grant. This would be more of, Bufnagely would have to self-fund its space program.
Oh, you think so?
I think so.
All right, and to self-fund,
unless you were going to do some real science along with the, unless that little minifig guy was planning on doing some real science.
But the way to do that, though, I think, is to sponsor like the local high school whatever club, and then we could get our sticker.
Yes, then okay. Now you're getting to a point where you might be able to compete for grants.
So it'd just be they would do the real work, and we would just be like the marketeers.
Yes.
All right, Harry, how'd your project today with the marketers go?
That was a really, really good segue, and as soon as you saw it, I smiled.
Yes.
Right, so for Bob and for Brian here, I just moved into a new house, and I guess for the listeners, I just moved into a new house, and I'm setting up my workbench. Right, so I bought a workbench from Lowe's, one of the 72-inch Cobalt workbenches, which is really nice, great flat surface, lots of room to work on. And then I bought some pegboard, some steel reinforced pegboard, which is modular. Right, so that's everything. Every piece is 16 inches by 32 inches. So your first thought is awesome. Why is it awesome? Because
can I answer?
Yeah, go for it.
Yeah, because studs in most of the houses are 16 inches on center.
The studs are 16 inches on center. So 16 inches by 32 inches, I should be able to line up 6 screws directly into the studs. Perfectly, no problem. Everything's modular. It all fit. The only difficulty I will have is leveling it. And that by itself is not difficult either. Until I realized that the modular pegboard system doesn't have the applied screw anchor points at 0, 16, and 32 inches.
Where are they, Harry? Where are they? Where were they located?
They're at approximately 2 inches, 14 inches,
So
24 inches and like 28 inches. So I couldn't even off center the pegboard.
I bet if you rotated
to get two things on it.
If you put it at an angle, it might have worked.
Oh man, it was
just no.
I was stunned. So I texted Rafe and called him about this. Like, have you ever had any problems with this type of thing? And he goes like, why are you having so much trouble with a 16 by 32 inch pegboard? Just line up the holes and it's good to go. But the anchor points on the backside didn't match up. And so I ended up just drilling through. It took a long screw, pre-drilled myself some holes and just put it through the pegboard, which was an applicable solution, until I realized that one of my stud parameters is 19 inches. So that one put me to shame a little bit. But we kind of talked about marketing 16 by 32. Perfect. But they didn't have somebody to quality control where it's going to be hung.
Yeah, it was interesting because I went then to the website and I looked up this product and everybody was like, how are you supposed to hang this with these anchors? and it was, it seems to me like it's a guy that just said, well, I know studs are 32 inches on centers. We'll do this. And somebody came up with it. It's a very neat attachment component, right, Harry? I mean, if they were in the right place, it would be wonderful.
Yeah, because the whole pegboard is probably off the wall by 3/4 of an inch or 5/8 or something. And then it's got a bracketed, I guess it's welded bracket to the backside that also acts as a buffer for the pegboard. And then it's got a hole in the center. So it's like a U shape with a hole in the center, with the ends of the U attached to the back of the pegboard. And all you got to do is go through the hole with the applied screws into the supposed stud.
That is not located at
That's
5
not
inches
located.
and 2 inches. Yeah.
So did it occur to either of you guys to do a horizontal runner that you could then screw into?
I could.
And screw into the studs?
But that would be needing to do a 25-minute drive to the hardware store because I don't really live nearby anything in particular. And then making sure I cut everything in the first place.
It's not a project unless you go to the hardware store at least once and also draw blood and buy a new tool.
Buy a tool, yes.
That's right. You always buy a tool.
I didn't want to leave that one out.
Well, that's because a couple of weeks ago I bought a new tool. I got a blowtorch out of it.
Nice. Any project where you have to buy a new tool is a good project.
So for the women listening to this Bufnagely podcast, it's a thing.
It really is.
4 men have confirmed it. Buy a new tool. You will always have to go back to the hardware store. It's just one of those rules of life.
All right. So the marketing, so you're saying, Harry, the marketing people and the engineering science people may or may not be completely lined up, and it would be best if they were?
Best if they were, or if the person in charge of both of them had them talk on some kind of basis.
Yeah. So, okay. So let me see if I can summarize where we are with this. And I haven't even got, so basically all the stuff is in place for me to do kind of what I want, except for me doing it on my own.
Yes.
All right. But I'm still kind of curious about the idea. What would it really take for me to do it on my own? Do I need how big fuel? Well, yeah, I think so. And I think you told me there's not a lot of benefit of going up to super what I'll call it
geosynchronous.
Above the atmosphere. It's not really helpful to get up there before I start going over. I might as well just start on the ground because
I didn't directly say that, but I very indirectly hinted at that. Yes, and
well, I picked that up.
That's good. That means you were listening.
Yeah. Okay. All right.
So it's a solved problem. I think your time would be best spent on the unsolved problems.
You have much alike with my wife's opinion on those sorts of things. Yeah. All right. Okay. So, all right. Well, I won't be. I bought some fertilizer a while back, and when I opened it up to put it on my lawn, the fertilizer was. I started pouring it into the fertilizer spreader, and it flows that wonderful granular fertilizer thing when it goes into the spreader. But then at the end, it kind of went clump, 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 splat, and it was wet on the inside, and so obviously it wouldn't go through the spreader because it kind of globbed it up. And you don't think I can use that as a propellant?
I'm not going to recommend it.
Yeah. Okay. That's good.
I don't know if that'd be illegal.
Then
You
there's
need
that.
oxygen.
Yeah, I would need. Well, there's oxygen in the air. I can get some oxygen. I can make oxygen from water.
Yeah, do that. Yeah, you do that,
Yeah. Yeah. Okay.
and then and make enough of it to propel your device.
My
I
fertilizer.
think we're all forgetting that Rafe's device is going to be approximately the size of half of a soda can empty.
Yeah, I really
All right,
wanted a
Rafe,
little tiny device.
The
But
thing,
okay.
I'm going to give you a homework assignment.
No. Okay. Okay. I will
And,
write this down.
and the homework assignment is to go look up the rocket equation. And the rocket
equation.
The rocket equation is a very harsh mistress. and I think actually that will answer more of your questions than you think.
Yeah.
You'll get to learn about all kinds of things like ISP at ground and in a vacuum and thrust to weight ratio and all kinds of fun stuff.
I figured that was coming. I just wondered if it scaled down enough if I was only launching something about the weight of an Estes rocket. Didn't you do an Estes rocket thing 100,000 years ago, Bob, when you were just a juvenile? Didn't you win a prize?
Years ago, yes.
Didn't you win a prize for
that? They had
won a free ride on the dinosaur.
They had a monthly contest. I entered in, actually not even a rocket. It was an electronic thing I did to count down. And actually count down from 9 to 0 and then launch the rocket.
In digital, little digital.
Yeah, with a single LED numeric 7-segment numeric display. And that won 1 month for real. And then the best part was like several years, like 4 or 5 years later, I was in a hobby store back when there were hobby stores, and they had made the product. They had made it into a product. And the thing I'm kicking myself about now is I didn't buy it, but I was a poor student. And I was like, I looked at it and said, wow, they made it. And then I put it back down because I didn't have the money.
It was Estes, or was the hobby store?
No, it was an Estes product.
Wow.
Yeah, it was cool.
And you got no royalties, no nothing.
I got the gift certificate for, Estes products, which I spent like half of it on engines.
Right. Okay.
And the rest on kits. Yeah.
All right. Well, that's awesome. Okay. All right. I will keep that in mind. All right. Any other pieces of information other than the rocket equation I need to do?
That's the biggest one.
All right. I will get on that. Bob,
and
thank you very
much. And then look up CubeSats.
CubeSats. Yeah, that's the thing. Not cube steaks.
Nope. CubeSats.
CubeSats. Okay. Bob, thank you very much. Brian, thank you very much. Harry, take us home.
Absolutely. I hope you guys all enjoyed this episode, learning more about rockets. You all have homework as well. It's the same as Rafe's. But in the meantime, remember to seek the good, live virtuously, and flourish, and enjoy the adventure of life. It's going to be a great day.